I want to show you practically what is elevation difference, what is a contour, and what is a vertical or horizontal interval. I presume that many of you might have some doubt regarding, because many of you might find it difficult to visualize 3D image into 2D image. We will try to show you practically, later also we will show you one topographic map. What are these contour lines? Say, understanding what is elevation difference or what is slope. Say there is a certain point on the ground, say A, another point B. The distance between A to B, there will be some horizontal distance, like from this place to some other place. This is your horizontal distance, or we call it horizontal interval. And if you observe this line, this is at certain elevation, say 550 meters above sea level, and say this is at 500 meters above sea level. This is the elevation or the height with reference to a certain benchmark, and the benchmark here is the mean sea level. And this horizontal distance interval will be the interval between these 2 points on the ground. To represent that here we use certain scale. Say 1 centimeter is equal to 100 meter on the ground. Say this is, say 20 centimeter, then it will be 20 into 20,000 meter, that is 20 kilometers. So distance between this and this is 20,000 kilometers. So what is then this vertical interval? This has got a certain elevation, this too has got a certain elevation. The distance between these two, vertical distance between these two is called the vertical interval. Say this is vertical interval, here it is 550, here it is 500, that is your 50 meters. And what is this line? This is the slope. And what is slope? Slope is Vi by Hi expressed in terms of percentage. Vi is elevation of this point minus the elevation of this point, that is 550 minus 500. Vi is 50 meters, and the horizontal distance is, we have found out, 20,000 meters. And the slope would be this, represented in terms of percentage is your slope. So 20 by 50, that is slope of this is 2.5. This is how you find the slope of any place. Second thing is the contour. Because this vertical interval, horizontal interval, in contour maps we call it horizontal equivalent. This forms the basis for any contour maps. Second says this is a small hillock. And what we do is, for making a contour map, manually, what we do is we find elevations at different points. This point, this point, this point. And we represent, this hill can be represented because it is a vast area. Say we have taken a contour interval of 10 meters. So at every 10 meters we have to draw one contour lines. And we take whole numbers for easy understanding. Say its value may range for say 500 to say 800 meter. Its value is ranging from 500 to 800 meter. And we have to draw contour lines at every 50 meters. So at 500, so each point will have certain contour intervals. There is a method for finding the contour map. How we find the contour map? Because since it is beyond the scope of your study in this course, so we are not dealing with that. There is something called grid method. We form a grid of say 10 meter, 15 meter, and we find the elevation in each point, and through interpolation we find the elevations. Say this is the contour line. Here its contour will come like this. Say something like this, because it would be drawn from the both sides. This is represents, say this is 600 meters. So this will be 600 meters. We are taking it 50 meter interval, and second would be 650 because it's a hill. Here and this is a 750. Say here it is 800. So this is the contour map of this hilo. This is how you find the contour maps. Now coming to, we were also discussed about the properties of contour lines. See, when two contour lines are runs very close to each other, what does it mean? The vertical interval is very less, that is at every 10 meters vertical interval you have the horizontal distance like this. The horizontal equivalent is, this is one horizontal equivalent and this is one horizontal equivalent. That means at smaller horizontal equivalent, the drop in height or height in is difference in elevation is very large. That means that place is very steep. So when in the properties, characteristics of contour, what we have learned, when two contour lines run close to each other, that means it is a very steep area. And if it is wide apart, that means, in this case, if it is wide apart, that means that area will be having a flatter, say, and next 50 meters comes here. So its contour will be like this. So difference between these two consecutive contours, the horizontal equivalent is large. That means this is a flatter area. So in the characteristics of contour, if two contours are placed wide apart, that means it's a flat land. If series of contours run close to each other, that means it's a steep land. And next property was like the contour line may represent a hill or a valley, depending upon the higher or the lower value. The value is inside the loop. The contour of this will be something similar to this, and this will be also be something similar to this, because forming a loop, it can either be a hill or a valley. So by simply looking at this contour, you cannot say it is a hill or valley unless you know the value. If the higher values are inside the loop, say this is 550, 500, 450, 400, then we can say this is the highest point, this is a hill. And if the lower values are inside the loop and the higher outside, 400, 450, 500 and 550, then it is a depression. Through the characteristics of contour line, we can also understand whether it's a ridge or a valley. What are ridges and valley? Why does river flow? River flow because of difference in elevation, difference in the height. So it will flow from the lowest area. Wherever water flows or there is chances of water to flow, whenever there is a rain, that represents a valley. And ridges are places from which contributes water to that valley. So in a contour map, both ridges and valley will look similar. Then you have to understand, depending upon the value of the contour, you can identify or you can distinguish whether it is a hill or a valley. How we can see? Say some contour is coming like this. इस तरह का आपका कंटूर आ रहा है. तो इसमें रिच कौन सा है, कौन सा वैली है, ये कैसे पता करेंगे? What you have to do is, and each and every contour has got a certain value. कंटूर का वैल्यू कहीं ना कहीं आपका टोपोग्राफिक मैप में दिया हुआ रहेगा. और सेकेंड थिंग, कैसे आप आइडेंटिफाई करेंगे? at every 5 consecutive contours, the lines that we get from the Survey of India maps, topographic map, it is made dark so that it is more easily identifiable. Normally we get the Survey of India map at a vertical interval of contour interval of 20 meters and the horizontal interval is 1 centimeter, 1 is to 50,000. So at every 5, after every 5 consecutive contours, there is dark line is made darkened. इस तरह का डार्क किया है और हर कंटूर पे एक वैल्यू रहेगा. कहीं ना कहीं कंटूर में या तो आपके मैप में रहेगा या उसके बाहर रहेगा, वैल्यू जरूर रहेगी. से इट हैज अ वैल्यू से 560, 540, 520, 500, 400, 480. एक पैटर्न रहेगा क्योंकि इट्स continuous. What you have to do is first you make a tangent along the tip of this map. Now draw a line along the tip of this map. Then draw one line perpendicular, draw one tangent. Now see, suppose the elevation at this point is contour value is 540. Here because first property of contours, each point in a contour line will have the same elevation. So here it is 540, here it is 540, here also it is 540. Here again it is 540. At this place it would be something more than 540. It would be, see, here the next line is of 560. This is 540. This will lie between 540 and 560. That is, this is at a higher elevation and this is at a lower elevation. And water will always flow from higher elevation to a lower elevation. So water will always flow from here to here. So the movement of water will be like this. That means this is a valley. That is, it has got a lowest point from where from higher reaches water is coming. This is a valley. So don't go by the shape of your contour map, go by the actual value you have to find which is a valley, which is a valley. Similarly this place. We draw another line along the this side of this contour map. Again draw one tangent here along the tip of this line. This will something. Do it here. Along the tip of this line. What is its value? Its value is 500 meter. The next contour, this 580. This is 480. This is 500. So this point, at this point the value is 500. All other points it is 500. At the tip also it is 500. And what is the value here? Little outside it would be between 480 and 500. That means something less than 500. So if rain falls, if water falls, the movement of water will be from the higher elevation to lower elevation. This is at higher elevation, this is at lower elevation. So this signifies that this is a ridge. This is a ridge. This is at higher elevation, this is at lower elevation. So this is a ridge. So by careful study of contour map, we can also identify which place is ridge, which place is valley. Why is it important? It is important because if we have to draw any irrigation channel, if we have to go for any drainage channel, we have to see along which line, which is the valley line, along which we have to construct that particular structure. These are some of the properties of contour lines, and in this more or less practical session, what we do is we will show you actual topographic map where we can see what are the different features of that particular map and how can we delineate a watershed and calculate the area of that watershed. Let's see the topographic map. See, this is a topographic map which we are talking about, which shows horizontal as well as the vertical interval. Whenever you see a map, the first thing that you have to do is see its scale and see the source. What is the source? This is a topographic map which is generally obtained from Survey of India offices. Anyone can have access to it by paying certain nominal fee. You can get the topographic map. And which map you have to get? Say the map which is required for your area, the place where you are working. So for that you have to tell them any specific location which place it is meant for. Or if you have the latitude and longitude, you can tell this latitude up to this latitude east to this latitude I have to take the topographic map. Then they will see from the list which topographic map. They will take out the topographic map of adjoining areas of the certain place. Say in Ranchi, Kake block you want. For Kake block, 1:50,000, there would be 2 or 3 such type of maps. And the location that you are talking about, they will find out. Say a particular place in Kake, you have to see, then they will find out, they tell you which code map you have to get. They will tell you, say Kake certain area, they will tell you, oh, this is the other place, adjacent place is this one, then your map should lie in this one, F45H2. Just for the case of illustration, I'm telling you. So this map you will get. So once you get this map, what you have to see is first see at the left hand corner top end, you see the scale. What is the scale? It is 1:50,000. That means 1 centimeter in this map, 1 centimeter here, 1 centimeter here will represent how much? 500 meter on this map. That is your horizontal equivalent also. That is your horizontal equivalent. And second thing that you have to see is its contour interval or the vertical interval, contour interval rather. The contour interval here you can see it is mentioned somewhere here. It is mentioned here. Contour interval as 20 meters. So this is a topographic map with horizontal scale. Horizontal scale as 1:50,000 and the vertical scale or the contour interval as 20 meter. That means at every 20 meter there is one contour. Now second thing, this is your entire map, that topographic map we are talking about. The special feature of a topographic map is it represents many features. Other than this scale, horizontal, other than mapping, horizontal mapping and vertical showing the elevations, you can also see many prominent places. See, you can see one river flowing through this and its branches and small branches, and there are many small rivulets colored in black color. You can see this. These are the rivulets, which are the small tributaries, small nalas, unseasonal. If there is rainfall, there would be through this elevation rain will go. So this is a valley. Actually, this is a valley. So you can see these also. Prominent roads are there. Wherever there is Kacha or Pakka road, Kacha road would be shown through dotted lines. Pakka road would be dark lines. Here you can see the Pakka roads. And also there are small ponds, and also the color coding. Like this is green, and here what can see this green color. Even the contours are. See where are the contours? These are the minute light lines which are passing through. These are the contour lines, and each contour line has got a value. And this green shaded area is the forest area, and this yellow shaded where the contours are placed rather comparatively at a two contours are placed wide apart. These are flatter land, and in this type of land you can see many dot points. These are the habitations. It means these are small hamlets or villages where habitation houses are there. These are also shown through a topographic map. But in a small contour map, when you study for a small area, then you make only the contours. So these features may not be included. And here these all features are existing. And this is the index. What are the symbols used for? So for culverts, it has got a certain symbol. For railway track, it has got a certain symbol. Kacha Pakka roads, it has got certain symbols. And if there is any railway tracks, there will be some symbols, water bodies as rivers, ponds, there are certain, this you can go through this. Now what I want to show you practically here is, first thing, what are the contours? Contours we have to observe very minutely. These are the lines, light yellow shaded lines which is running close to each other. These are the contour lines, and at the end of this map and also in between there are contour values attached to it. Say this is 400, that means the value of this contour is 400, and each contour at every 5 consecutive contour it is purposely made darker so that it can be easily visible, and through the study of this contour we can find whether it's a mountainous area, hilly slopes. See, like these are the hilly areas, mountains, forested area, protected and reserved forest. See here you see the contours, they are very close to each other. But here if you see this yellow dotted lines, light lines, these are completely spaced apart. That means this is a flatter area. That's why you have the habitations also. Now what we can do is, for proper study of it, practically you have to do it. But given the constraints we are trying to explain you, what we can, through this, one of the uses of contour line is to gauge the area, whether it is a flat, undulating. With this we can find out through study of contour line. Also we can find out the area, how much is the watershed area. What is a watershed? As I told you, watershed is an area from where, if rainfall occurs, water will flow from a unit common outlet. The entire area which contribute to that outlet is called a watershed area. Say suppose there are many watersheds, even the place where we stand, this also comes under some watershed. Say this is a watershed, this is an outlet. Say this is an outlet. So this small rivulet or dry channel, nala, is contributing some water, if there is some, in case of river, to this area. So if you have to trace the watershed area, which is the area from where the water contributes up to this point. If we consider this as outlet, the area from where water contributes can be traced. See, these are the valleys, small dark lines, these are the valley lines through the contours where the water can flow if there is rainfall. You have to trace along the ridges because water will flow from ridge to valley. So we have to find the which one is the ridge from this topographic map. You have to trace it. Once it is traced, it can be put in the graph paper and we can convert it, find the area of this particular area. Let's see how we can do it. What we'll do is we'll take a tracing paper and we will superimpose the tracing paper in this outlet and try to form a watershed area. See, this is the valley line from where water is coming, and if there is a valley, certainly there will be a ridge because water flows from ridge to valley. And see, if you see the next area adjoining to it, there is some other rivulets contributing to some other watershed like this. That means this is a ridge. This is a ridge area. You can also see through the contours. You can identify if you see it minutely, and if you apply the characteristics of contour lines which separates ridges and valley, what you can do is you can trace from here. So say this is one watershed. Water is contributing from this side, that means, and there is some contribution of water here from to some other watershed, that the ridge will pass through these lines. We have to see the drainage line or the valley. Here see water is passing through this ridge to this valley, and some water is passing from this to some other watershed. Then this is a ridge line. So ridge line separates two valleys. So here it contributes to some other watershed. So we have to draw this along this ridge line. Here there could be some approximation because of lack of time. So this is one watershed that we have drawn. Now, it might not be very clear to you. We'll go for a smaller watershed, which is more clearer. See this point. This, if we consider this as the outlet, from where this water is contributing, it is contributing from this much area. Is it contributing from here? It is not, because this water, this is a valley which is contributing to some other watershed. So we have to trace it along the, see there are undulating lines which can either be ridge or a valley. See, this is a valley, that's why water, this is not actually water, it is a depression area. If there is rainfall, water will, what we, जो हम लोग प्लेन भाषा में सरल शब्दों में बोलते हैं कि ना इसमें बरसाती पानी यहाँ से बह सकता है. तो ये नाला का एक शेप है, यदि बरसात होगा तो यहाँ से पानी निकलेगा. तो ये जो आपका रिज और वैली है, तो इसको आप उसकी प्रॉपर्टी के हिसाब से आइडेंटिफाई करना पड़ेगा. और सबसे सरल तरीका ये है कि कहीं से यदि आपका वैली निकलता है, उसका जस्ट करस्पॉन्डिंग एरिया, उसके जस्ट ऊपर वाला एरिया आपका रिज होगा. तो यदि हम इसको हम आउटलेट मानते हैं वाटरशेड का, कैचमेंट एरिया का, सो एनी वाटरशेड और ए कैचमेंट डज नॉट हैव वैल्यू अनलेस दैट इट्स आउटलेट इज डिफाइंड. इसको हम आउटलेट मान लेते तो इसका एरिया इतना होगा. यदि हम इसको आउटलेट मानेंगे तो इसका एरिया और बड़ा होगा, बिकॉज इतने ज़्यादा एरिया से कंट्रीब्यूट होता है. फॉर सिंप्लिसिटी वी आर टेकिंग दिस एज आउटलेट. तो हम वी हैव टू गो, what we have to do is we have to put this tracing paper here again. This is our outlet. So along the ridge you have to draw the, it's demarcate its boundary. So see, there is another line going, but it is contributing to some other watershed. So because of some visibility problem there is, so this is your watershed area. So say suppose any developmental work has to be carried out in this area. So first what we have to do is, we have to find what is the total area. How will we find total area? We cannot go and measure the length and breadth, but through this topographic map we can find out. In the office itself we can find out what is the area of that particular place in question. So this we have traced. Now what we do is, we have to take one graph paper, delineated area on a graph paper, right? So what is graph paper is, you know, we have got certain division. See, each it is divided into many grids, right? See, each grid is 1 centimeter by 1 centimeter. See, this is 1 centimeter, this is 1 centimeter, right? And even within 1 centimeter, again subdivided into 4 parts, shown by a little darker line, and 4 parts. Then again this one part is equal to 25 subdivisions. You can see small divisions. So this is 1 centimeter by 1 centimeter. And what is the scale of our map? Is 1:50,000. That means 1 centimeter is equal to 500 meter. 1 centimeter on this map is equal to 500 centimeter on the ground. So here 1 centimeter or 1 square centimeter will represent. So 1 square centimeter here will represent how much? 500 meter by 500 meter. That is 25,000 square centimeter. How much is 25,000 square meters? 1,000 square meter is 1 hectare. If it is 25,000 square meter, then it will be 25 hectares. So one grid in this graph paper represent 25 hectares. So how much is the total area of the traced watershed? We can find out. Now what we have to do is, we have to see how many such type of grids our traced watershed is making. Say this, how many full grids? There is one grid, here second grid, and say this is third grid. This is not making a full grid, but it would, since one grid is 100 subdivisions, 75 this again divided into three parts, and the fourth part is taking some subdivisions. Say this is 90 subdivisions. These are full grids, right? Say this one, if we count, if it is counting can be made easy if you take it part wise. This is one part is there, two part is there, third part, some portion of third part and fourth part is there. That means it would be around 80, just for sake of making you understanding, putting a figure. So this is only one full part is there, some part in the fourth grid, say around 30 is there. So here two full parts are there, in one grid two full parts is there, some parts from this are there, say this is 70, and similarly say this is 80 and this is 60. That means we have got what we have got is we have got three full parts. That means three grids plus 80 plus 90 plus 30 plus 70 plus 80 plus 60 again. That is 440 subdivisions. One grid is how many subdivisions? 100. That is 4.4. That is 3 plus 4.4. That is 7.4 square centimeters are there in this watershed. That means 1 square centimeter is equal to how much? 25 hectares. If we have 7.4 square centimeters, that will be 7.4 into 25 hectare. That would be around 185 hectares. So the area of this watershed in question, or the traced area, is 1 hectare. Suppose here we have to construct say a check dam or a gully control structure, and we have to give the estimate for the entire area. What are the structures? First we have to define how much area is there in this particular watershed, and this we can do it through contour maps. This is one of the many uses of contour maps. Just for the sake of your understanding, I have told you one use, and many other uses. Maybe it's not, it would be beyond your scope of your course. One use, this is very important and very practical in nature. I have tried to tell you through this contour maps. So that's all for today, and I hope you are getting whatever I am trying to convey. And if there is any doubt, we can always be in contact through phone or through emails. Thank you very much. Since the last 15-20 days, many lectures are being recorded and uploaded, and we are coming and giving lectures, and we are getting it uploaded. But there are many people who are involved in it, so that these lectures are uploaded in time. So you should be very thankful to them. I would like to introduce two people who are with this process since May end till now, still continuing. More than 50 lectures has been uploaded of different subjects: agriculture engineering, soil science, maybe which is being widely seen by most of you, and also I think you are getting benefited. So I would like to introduce Shri Dharmender Rawalji, who is the brainchild behind this. Earlier, through Zoom platform or Google Meet, we are trying to contact students, especially agriculture engineering, College of Agriculture Engineering students. We have been taking classes from April to May, but the response was good, but due to connectivity problem, so all could not participate. Few got benefited with it. But when I took this problem to our Dean Agriculture and also Shri Dharmender Rawalji, he suggested such type of intervention which can have a wider range, more people, more students, who, even if they are not staying where internet facility is there, they can also access at a later time. So he suggested this idea. I would like to bring him on the camera because Sri Dharmender Rawal ji and Sri Jay. Dharmender Rawal ji is the official photographer, and not only for this university, but he is a very renowned photographer of Ranchi, and we are very lucky to have him in BAU. So Dharmender ji, please come. और सर ये बोलने क्या क्या प्रोसेस है इसको करने में?
इस लॉकडाउन में हम अपने टीचर्स को रिकॉर्ड कर रहे हैं और उसकी फाइनल एडिटिंग विद स्लाइड्स के साथ कंपाइल करके वो हम YouTube पे अपलोड कर रहे हैं। मुझे लगता है कि आप इसको आराम से एसेस कर रहे होंगे और एवरीडे हम उसमें क्वालिटी इम्प्रूवमेंट के लिए काम कर रहे हैं। तो कमिंग लेक्चर्स में आपको अच्छे से अच्छा प्रेजेंटेशन जाए, ये हमारा प्रयास है। थैंक यू।
और ये भी बता दें कि जो हम लोग 1 घंटे या आधा घंटे का लेक्चर देते हैं उसके पीछे कम से कम इनको 3 से 4 घंटा लगता है उसको एडिट करने में, अपलोड करने में। सिर्फ एक लेक्चर नहीं रहता है, एक दिन में 3-4 लेक्चर रहता है। और उनको असिस्ट कर रहा है श्री जय, ही इज़ अ ग्राफिक डिज़ाइनर एंड ऑल्सो ही इज़ एसोसिएटेड विद हिम for the past 15-20 days. Jay, please.
Sure, sir. Thank you very much. And hope you are liking the videos which we are uploading. And the presentations are clear to you as we are currently improving day by day so that you can get more clarity of the lecture along with the highlights which teacher are. Basically the idea is the teachers information what they are providing through the lectures should be very clear to you. So this is our objective and we are working in this scenario. Thank you so much.
And also it would be injustice to the other supporting staffs like Shri Shikandar, Amardeep, who are also helping in other ways, to not to mention them. So Amardeep and Sikandar, they are also involved in this process. So kindly acknowledge them also, all the people who are involved. It's a teamwork. Also, above all, the Dean Agriculture who has taken such initiative, given such platform and facility to everyone. All teachers, thank you.